Hi, this is our statics problem, finding support reactions in a loaded beam. In this problem, we're going to analyze a beam that's 120 inches long, which is supported by a pin at point A and a roller at point B. Also, two downward load acts on the beam, one that's 800 pounds, that's 30 inches away from the left support, and one that's 1,600 pounds, 80 inches away from the left support. Our goal is to figure out how much force each support is holding. The pin at A can hold force sidewards and upwards, so it has two unknown. The roller at B only holds force upwards, so it has one unknown. We'll use the three equilibrium equations to find them. Here are our knowns and unknowns. Starting with the knowns, we know that the beam is 120 inches long. There's an 800-pound load located 30 inches from A. There's a 1,600-pound load located 80 inches from A. The roller at B is 40 inches away from the second load. The pin at A can support horizontal and vertical forces, and the roller at B can only support vertical forces. Our unknowns is AX, which is the horizontal reaction at A, AY, which is the vertical reaction at A, and then BY, which is the vertical reaction at B. Here's our full body diagram. It shows the beam that's 120 inches long with support at each end, and then it shows that point A has pin support, so it provides AY and AX, and then point B, which only provides BY. So this is our real world example. Imagine a barbell resting across two squat rack hooks. If you place one 800-pound weight plate near the left side of the bar and a 1,600-pound plate farther to the right, each hook has to support a different amount of weight depending on the hook closer to the heavier plate will hold more forces and the other hook will carry less. This is exactly what our beam problem represents because we're figuring out how much load each rack hook needs to support based on where the weights are placed on the bar.
Hi, I'm Juan Cabezas, and this is part 3 of generating a solution. So this is the image for our problem, and we have point A, point B, and two loads on our beam, both located at different distances and with different weights for each load. So what we're trying to find in this problem is the horizontal reaction at A, the vertical reaction at A, and the vertical reaction at B. These are known quantities which we deducted from the picture in the previous. So here, we know that there are no horizontal loads in the problem. So the sum of all forces on the X can then be translated to the forces, horizontal forces on A, which equals 0. So the horizontal reaction at A must be 0. Then we have the moment of equilibrium about point A. So here's where we start solving for our BY and our AY. W1 creates a clockwise moment about A, so that means it is negative. And we have negative 800 times 30, so the weight of our first load times the distance from A to our first load. So we're using A as our main reference point here for both our weights. Oh, sorry. Okay, we have W2, which also creates a clockwise moment, clockwise moment about A. So that's also negative W2 times WT, or 2, which is negative 1600 times 80. And then we have BY, which creates a counterclockwise moment about A. So we get this equation down here. And now we just plug all of this back in, and we get BY times our length minus the weight of our first load times the distance from A to our first load minus the weight of our second load times the distance of A to our second load equals 0. So we rearrange that, and we solve that out, and we get that BY equals 1,267 pounds of upward force. And now that we have that, we use this equation, which is AY plus BY minus the first load minus the second load, and we can find out what AY is by solving this out. So we get that AY is 1,133 pounds. So in conclusion, we used
to get real numerical results. So the beam has a total length of 120 inches with a pin support at point A and a relative support at point B. Because of these support types, point A can resist both horizontal and vertical forces, and point B can only resist a vertical force. That gives us three unknown reactions: a horizontal reaction AX, a vertical reaction AY, and a vertical reaction at B, which is BY. The beam also has two downward loads acting on it, an 800-pound force located 30 inches from A and a 1,600-pound force located 80 inches from A. Before solving, it's important to set up the free body diagram clearly and label all known distances and unknown forces. The first equilibrium equation we apply is the horizontal force equation. Since there are no horizontal loads acting on the beam, the horizontal reaction must be 0, so we have AX equals 0. Next, to solve for the reaction at point B, we take the moment about point A. Taking moments about A eliminates both the reactions at A, so the only loads in the reaction at B remain. The equation
I'm Mario, and in this step I do the verify and test solution part. First, I check the vertical force balance. The upward forces from the supports are 1,133 plus 1,267, which add up to 2,400 pounds. The downward forces are 800 plus 1,600, adding up to 2,400 pounds. Since they match, the sum of vertical forces is 0, meaning it's in equilibrium. Next, I check the moment